Welcome dear students. This topic is the heart of the organic chemistry and that is the functional groups. Look at this molecule of the ethyl chloride. It has a hydrocarbon portion which contains ethyl group and there is an atom of the chlorine that is a single atom, and in this portion you can see that there are two carbon atoms and five hydrogen atoms. So this one is the bulkier portion and this one is the lighter portion having only single chlorine atom. In case of ethyl alcohols, again, this one is the hydrocarbon portion and a group of two atoms, hydroxyl group is attached with it. In case of, my dear students, alkene, there is carbon-carbon double bond, and in case of alkynes, there is carbon-carbon triple bond. Now, there is a question that whether the chemical properties of all these molecules, which are determined by ethyl group or the Cl group and OH group, will decide the chemical properties of these two compounds. Dear students, please understand this, that this one is the hydrocarbon portion, which is the heavier portion, but the chemical properties of both these compounds, they are not decided by their hydrocarbon portion. The single chlorine atom and the group of two atoms, that is hydroxyl group, these are the active groups in these molecules, and actually they decide the chemical behavior of these two molecules. In the same way, in case of alkenes, carbon-carbon double bond and carbon-carbon triple bond, that decides the chemical properties of the alkenes and alkynes. It means that the functional group is actually the active part of the organic compound. It can be a single atom, it can be a group of atoms, or it can be multiple bonds, either double or triple bonds. So these are the functional parts that will decide the chemical behavior of the organic compound. My dear students, this alcohol, it has two carbon atoms, but this organic compound, it has three carbon atoms. So their chemical behavior should be different from each other as the number of carbon atoms are different. But it is very important to note down that the chemical properties shown by both these compounds, they are same just because of the reason that their functional group is same. It means functional group is the main part of the organic compound which decides the chemical behavior of the organic compound. Now let us define the functional groups. Functional group may be an atom or group of atoms or multiple bonds which are responsible for unique chemical reactions of a substance. The overall chemical behavior, the chemical reactions, chemical properties of any organic compound, that is decided by an active group present in that organic compound, and that is called as its functional group. So all chemical properties are decided by the functional groups actually. Now there are so many functional groups, but we are going to discuss some of the important functional groups of the organic compounds. You can see that this one is a list of those functional groups that carry oxygen atom. The OH is called as hydroxyl group, and the class which contains OH group, that is called as alcohol, and its simplest member is methanol CH3OH. This one is the formyl group, and the class which contains this formyl group as the functional group is called as aldehydes, and its simplest member is methanol. Similarly, this one is the keto functional group, and the class which contains this functional group, they are called as the ketones, and the simplest member is acetone. This one is the carboxyl group, and the class which contains the carboxyl group, they are called as the carboxylic acids because they show the acidic properties, and the simplest member of the carboxylic acids is the formic acid. In the same way, if two alkyl groups or aryl groups are bonded to oxygen atom, then this one is the ether linkage, and the class is called as ethers, and the simplest member of the ethers is dimethyl ether. If the functional group C double bond OR is present, then that is called as the esters. This one is the ester linkage. The class is called as the esters, and the simplest member of the esters, that is methyl acetate. Methyl formate can also be one of the members. Similarly, if this linkage is present, it is called as acid anhydride linkage. The class is acid anhydride, and an famous example is acetic anhydride, which is produced by removing one water molecules from two acetic acid molecules. Similarly, this one is the RC double bond OX. It is a acid halide. It is derivative of basically carboxylic acid, and example is acetyl chloride. If this functional group is present, in this case, this one is the functional group. If this functional group is present, then that is called as acid amide, and one of the famous members is the acid amide. My dear students, the acid anhydride, acid halide, and acid amide, they are basically functional group derivatives of the carboxylic acid. So this was the list of all those famous functional groups that are oxygen carrying functional groups basically. Now let us talk about those functional groups which are nitrogen carrying functional groups. My dear students, if NH2 group is present, if NH2 group is present, then that is called as the amine group. And if this NH2 group is present in a class, it is called as primary amines. And one of the example is the methyl amine. If NH functional group is present, which is attached to two alkyl groups, this is 2-degree amines. This is called as secondary amine group, and one of the example is dimethylamine. Similarly, if the nitrogen is there which is attached directly to three alkyl or aryl groups, this is tertiary amine group, and the class is tertiary amines or 3-degree amines, and an example is trimethylamine. In the same way, if this functional group is present in any organic compound, then that is called as imides. And my dear students, one of the example is the succinimide. RCN, if the CN group is present, this class is called as cyanides or nitriles, and this functional group is the cyano group. And my dear students, example is the methyl cyanide. In the same way, if ROCN, this OCN is the functional group, this class is cyanates, and methyl cyanate is an example. You have already discussed in the books of organic chemistry about the ammonium cyanate, which is used to prepare urea in the laboratory. And if NCO functional group is present, this is called as isocyanate, and one of the examples is the methyl isocyanate. So this one is a list of all those functional groups that are basically nitrogen carrying functional groups. My dear students, let us now talk about those functional groups which are basically the sulfur containing functional groups. Now there is a class in which SH group is present. They are thiols or merceptins. Merceptins mean mercury acceptors. They react with the compounds that contain mercury and they extract mercury from them. That's why they are called as the mercury acceptors or merceptins. And they are basically the sulfur analogues of the alcohols, because here is the sulfur, but in case of alcohols, the group is OH. So basically the difference is that in alcohols, O is present, and in thiols, sulfur is present instead of the oxygen, and one of the example is the methyl thiol. Similarly, this one is a sulfide or thioethers because they are sulfur analogues of the ethers. In ethers, instead of this sulfur, oxygen is present, so they are sulfur analogues of ethers. They are also called as sulfides, and simplest example is dimethyl sulfide. In case if the two sulfide linkages are present, then they are called as the disulfides, and these disulfide linkages are very common in the proteins, and one of the example is the cysteine, which is formed by the condensation of the two cysteine molecules. In the same way, this is sulf oxide group, and diphenyl sulfoxide is an example. This functional group is called as the sulf oxide group. In the same way, my dear students, this one is the sulfone. This functional group is called as sulfone group, and the class they are called as sulfones. Dimethyl sulfone is an example. This one is very famous. This is sulfonic acid group, and the benzene sulfonic acid you can see in the aromatic hydrocarbons. There is a benzene sulfonic acid group, and similarly there is SO2H, that is sulfonic acid group, and benzene sulfonic acid is an example. So this one is the list of those functional groups that are sulfur containing. That was the list of all those functional groups that were nitrogen containing. In the same way, this was the list of oxygen containing functional groups. I have already discussed that a single halogen atom, it also acts as a functional group, that is called as the halo group. In the same way, the double and triple bond, carbon carbon double bond and carbon carbon triple bond, they can also act as the functional groups. So these are some most important functional groups. Otherwise, the list of the functional groups, that is very huge, and we cannot discuss all the functional groups in this lecture. Reason being, the time is due to the shortage of the time and due to less importance of those functional groups. Now, my dear students, Sometimes an organic compound has more than one functional group. They are called as the polyfunctional compounds. Just like you will study in the chapter of the aldehydes and ketones, that cyanohydrins are the product when HCN is added to the aldehydes and ketones. It has two functional groups, cyano group and OH group, and they are called as the cyanohydrins. Similarly, in the chapter of aldehydes and ketone, you will see this compound which is beta hydroxy aldehydes. Basically, they have aldehyde group as well as the alcoholic group, so that's why they are called as the aldols. And my dear students, when an organic compound has more than one functional group, then both the functional groups, they show their individual identity and they show their individual chemical behaviors, and these compounds are called as the polyfunctional compounds. Now, what is the importance of this concept of the functional groups? My dear students, functional groups are very important because they decide the chemical properties of organic compounds, as we have already discussed. And the nomenclature, it mean the system of naming, whether it is the common system or IUPAC system, that depends on the nature of the functional groups. Similarly, the classification of the organic compounds in different classes and series, that also depends on the nature of the functional groups. And when we talk about the classification of the organic compounds, we come across a term which is called as the homologous series. Now let us discuss what is meant by the homologous series. My dear students, homologous series is basically a series of organic compound in which two adjacent member, mean the two closest member of the series, they differ by only CH2 group. And this CH2 group is called as the methylene group, and the mass of the carbon is 12 and the mass of two hydrogen atoms, that will be 2. It means that the difference of molar mass between the two members of this series, that will be basically 14 grams per mole. Now let us see an example of the class of the homologous series, and we are talking about the alcohols. My dear students, the simplest alcohol is methanol. Now next one is ethanol. You can see the difference between methanol and ethanol is of the CH2 group. By adding another CH2 group, you will get next member of the series, which is propanol. Then adding another CH2 group, you will get butanol. And similarly, you will keep on adding CH2 groups, and the next members of the homologous series will be produced. The mass of methanol is 32 grams per mole. By adding 14, it will become 46. Then by adding 14, it will become 60. By adding 14, it will become 74. So the difference of the mass between two adjacent members of the homologous series, that is 14 grams per mole, due to difference of this CH2 group. Now, what are the characteristic features of the homologous series? All members of one homologous series, they always have same functional group. Just like these alcohols, they all have same functional group, which is the OH group. And because the functional group is same, then their chemical properties are also same, although their masses, their molecular formulas, that are different from each other, but still because of the same functional group, they will be showing the same chemical reactions. But my dear students, you know that the physical properties, they basically depend on the molar mass. So that's why there will be difference in the physical properties. They will be having different melting points, boiling points, but the change will be gradual. Mean if the there is difference of like 20 to 30 degrees C of the boiling point of the adjacent members of the alkanes. So if you will memorize the physical constants of one member of the homologous series, you can predict the physical constants of the next member of that homologous series, because of this gradual change in the physical properties. They have same methods of preparation. All they can be prepared by same methods. Just like you know that the alcohols, they can be produced by the hydration of the alkenes. So all alcohols almost they can be prepared. They have same general formula. One homologous series have one general formula which represents their molecular formula actually. Just like the alcohols, general formula is CnH2n plus 2O. Alkanes CnH2n plus 2, alkenes CnH2n. Similarly for alkynes, that is CnH2n minus 2. So one homologous series that has one general formula. But the members of homologous series, they no doubt they have different common and IUPAC names. So the study of a large number of the organic compounds, like we have almost 7 million organic compounds discovered so far, that becomes very difficult if we will study the organic compounds on individual level. But studying the homologous series, that makes the study of the organic compounds very simple, because all members of a homologous series, they will be having same methods of preparation, same chemical properties, they will be having gradual change in their physical properties, their general formula will be same. So studying one, two, or four, five members of one homologous series will complete the study of the homologous series. So this concept of the homologous series, that makes the study of the organic compound very simple. My dear students, this was all about the concept of the functional groups and homologous series. If you ever find any problem in this topic, you can ask in the comment section. Being a teacher, I will always be there to help you out. Till then, take care.